Hello ladies and gentlemen, today's lesson is moving straight ahead 3.2 and we're going to be exploring equality. And today's lesson is on page 48 and 51, A through D. Our ACE problems are going to be 5 through 9, 31 through 33, and 38. And our learning target is I can use equality to solve for a missing variable. Let's get started. All right, so here are your notes for today. We want to make sure we got our page numbers 48 and 51. Through 51, name, date, and crew, lesson 3.2 notes. We want to put these things down. First is variable, a symbol used in place of a number within an equation. Okay, variables can have a single value or many different values. So for example, we could have x, or we could have y, or we could have n. Any of these things could be used as different variables. Basically, it's just a symbol in place of a number. And the property equality states that values on one side of an equal sign must be equal on the other side of an equal sign. So if a soda costs 60 cents for a soda, and our equation is n times 60 is going to give us our cost. If I give us a cost of 120 cents, we know that a certain number of sodas times 0.6 must equal 160. Okay? And you can pretty much figure that out. There's only one answer that can make this true. In order for this to be equal, in order for this side to equal that side, n has to be 2. Okay? We'll get more into what's actually going on here later. Now, equations mean just that. Things are equal in an equation. That 5 plus whatever x is must equal 12. Okay? So for instance, if I have 5 pennies on one side of here, plus an unknown box or bag labeled x, it is equal to 12. Well, in order to figure out what's in that bag, I'm going to subtract 5 from this side. But I'm not equal. Now, my scale is going to dip down. So I have to subtract 5 from this side. And in order to balance out and make these two values equal. And what I'm left with is 7. So, similar to this, by subtracting 5 from both sides of my equation, okay, the 5's cancel out, and I'm left with x by itself equals 7. And I've proven that x equals 7. In your book, they're going to explain this as the variables as sort of pouches, where we don't know what's in the pouch, but we do know that this pouch equals some value, or this pouch, or 3 of these pouches plus a couple pennies is going to equal what's on the other side. And you, by subtracting and dividing and multiplying, we're going to figure out what's in that pouch. So for instance, if I have 5 plus x equals 12, well, we just did this one. And I subtract 5 from both sides, I end up with x equals 7. Now, I've got 5x minus 5 equals 20. Well, I want to get 5 by the x here by itself. So the first thing I'm going to do is I'm going to add 5 to each side. Okay, so I get rid of that negative value, and I'm left with 5x equals 25. And I know that 5 x's, 5 of those mystery pouches, equal 25. So by dividing both sides by 5, I cancel out that number in front of the variable. And I'm left with x equals 25 fifths, or 25 divided by 5 could just be 5. And I know it's true because if I take 5 times 5 minus 5, see, I just plugged this in there, it ends up equaling 20, because 5 times 5 is 25, minus 5 is 20. So I figured out what was in that variable, and I can prove that it's right by plugging that value back into my equation and making it true. Okay, here's a couple other problems. I have 3x plus 5 equals 20. Well, I'm going to subtract 5 from both sides because I want that 3x by itself. And when I do that, I end up getting 3x equals 15. And my next step is to divide both sides by 3 because I want that x completely by itself. And 3 divided by 3 is 1. So I'm left with x equals 15 divided by 3, which is 5. And again, if I plug this in, 3 times 5 is 15 plus 5 equals 20. So I know it has to be true. Okay, slightly bigger one here. 20 minus 2x gives me 100. Now this is going to be a little tricky. I want to get rid of that 20. So I'm going to subtract 20 from both sides of the problem. And what I'm left with is negative 2x. Remember that negative didn't go away. Equals 80. Well, now I have to divide. But I want to get rid of that negative 2. And if I divide negative 2 by negative 2, I end up getting positive 1x. Okay? Because a negative divided by negative is a positive. But if I do 80 divided by negative 2, I end up getting negative 40 as my answer. And if you plugged this in, okay, 20 minus a negative 80, well, I'm subtracting a negative 80, I would end up getting 100, positive 100. Okay, your work for today is exploring equality. The lesson is page 48 and 51, A through D. And then you'll have to do the ACE problems 5 through 9, 31 through 33, and 38. Have fun.